To another present here. Welcome to the lecture series of data science and analytics, in which we are going to see Hive architecture. In the last lecture we have seen what is an Hive and what is the basic architecture and what are the components involved in Hive. But in this lecture series we are going to see the Hive architecture. So what is a Hive? So Hive is an data warehouse system which is also commonly called as Apache Hive, which is built on top of Hadoop ecosystem, so that it is used for processing large data sets. So here we are going to see Apache Hive architecture. It is mainly designed for data summarization, query and analysis of large data sets stored in the Hadoop distributed file system. So it abstracts the complexity of Hadoop MapReduce by providing an SQL-like interface called HiveQL. So in which we can run the SQL-like queries, so that we can convert the SQL queries into an map reduce jobs. So the components behind the Hive architecture includes user interface, compiler and metastore, driver, execution engine and Hadoop distributed file system. So first we will see what is an user interface. So interfaces like Hive CLI, Beeline or JDBC ODBC drivers are used to submit queries to Hive. So users write queries in HiveQL, a SQL-like language, and also we have a compiler in the Hive architecture which translates HiveQL statements into MapReduce, test and Spark jobs, which performs tasks like semantic analysis, type checking and query optimization. And also the metastore, which is a central repository for storing metadata like schemas, tables, partitions, uses a relational database like MySQL and PostgreSQL. It is essential for query planning and execution. And also the driver, which manages the lifecycle of an HiveQL query, receives a query, compiles it, optimizes it and executes it finally. It also acts like a controller coordinating between the compiler, metastore and execution engine. And we are going to see what is execution engine, which executes the query plan by interacting with Hadoop components. We also use MapReduce like traditional but slower, Apache Test DAG based faster and Apache Spark in memory very fast. The last component we are going to see is the Hadoop distributed file system, the storage layer for Hive data. Tables and partitions are stored as directories in files in HDFS and also often called as ORC, Parquet or text formats. So these are the main components involved in the Hive architecture. So for understanding the Hive architecture, we are going to a real-time example in which an Apache Hive is generally a data warehouse system which simplifies a big data querying, and also it converts your SQL queries into a distributed MapReduce jobs for scalability and also for fault tolerance. So the components mainly involved metastore, driver, compiler, executor and also the HDFS. So here the metastore, central repository for metadata. So the main role of the metastore is for storing the schema and metadata and also the table definitions, their partitions and databases. So it is very compatible with the Apache Derby, MySQL, PostgreSQL for metadata storage. And also the retail company uses MySQL metastore to unify product and customer data for analytics. And the next component is your driver, which acts as an interface for query execution. And the main function of the driver is to receive the SQL queries and manages their execution lifecycle. And also it handles the session management and authentication for users. So financial firms connect BI tools via JDBC driver for querying the database datasets. And also the compiler, which is used to, like SQL, it converts your SQL queries into a MapReduce jobs, and also it has parsing, planning, code generation. So next is the optimizer for enhancing your query performance. So it uses pre-dedicate push down, join, reordering and cost based optimization for better optimization of the query, and also it reduces data scan, speeding up query results. So finally the executor, which executes, runs the MapReduce or Spark jobs on the Hadoop cluster, and also handles scheduling, monitoring and resource allocation. So social media company analyzes the massive tweet volumes for sentiment analysis. And the user defined functions, like for extending your Hive compatibilities, it create tailored functions for unique data processing needs. So it also supports Java, Python programming and languages. Thank you.